Hey guys, this is Angles Day 3, and we are just going to be doing more of what we've been doing for the last few days. We're going to be using our blue reference cards that you have printed with all of the angles rules on them, and we are going to just be, by the process of elimination and logic, finding the measures of angles by going through what we know. So let's get started. All right, the first one on your notes says, in this figure, WXYZ is a parallelogram, ZV equals ZW, angle ZVW is 52 degrees, and VWX is a straight line. And we want to find angle XYZ, so that's this guy right here. Okay, well, let's start at the top of that description and let's just start marking what we know. So we know that this is a parallelogram. So if that's a parallelogram, right away we know that opposite sides are equal length. So let's go ahead and mark those with some little dashes, and then these two sides are of equal length. Also with a parallelogram, we know that opposite angles are equal. So let's mark those. Those are going to be equal. What else do we know about parallelograms? Well, we know that consecutive angles in a parallelogram add up to 180, so we may or may not need to know that. Okay, let's see what else we know here. It says ZV equals ZW, so that is convenient. This line equals this line right here, so this line actually also equals this line. Don't know if we're going to need to know that yet, but looks like that makes this an isosceles triangle. If that's true, then we know that the base angles are also the same, because the angles opposite the equal sides in an isosceles triangle are the same. And it says VWX is a straight line, so let's go ahead and mark that. This is a straight line, and that will help us, because if we know that that's a straight line, we know that the measure of this angle right here is going to be 180 minus 52, because these are supplementary angles right here and here. Okay, so let's start here with the first angle that we have on our notes. It says angle ZWV. That's this guy right here, and we already marked that down. That is 52 degrees. We knew that because it was the other base angle in that isosceles triangle. And then since we know that, we also can figure out angle ZWX. So that's this guy right here that we were talking about. That's going to be 180 minus 52 degrees. So let's figure that out. Should be about 128, but let's just make sure. Okay, so we have 128 degrees right there. And then angle XYZ, so that's this one up here. Well, we don't even need to do any more math for that, because it's an opposite angle in the parallelogram to the one that we just found. So that is also going to equal 128 degrees. All right, so that's what we're doing today. We're going to use our colored pencils. We're going to keep marking everything we know and filling in angles until we find the one we want. So let's move on to the next one. This is number 5 on your notes. It says, in the figure, ABCE is a square, AC equals CD, and BCD is a straight line. Find angle ACE. So that's this one right here. We'll put a question mark by that. And angle CDA. So we'll put a question mark by that one. Okay, let's mark what we know. ABC is a square. Well, if it's a square, we know that all of those sides are equal. We know that the angles all add up to 90 degrees. So when we're looking at this figure right here, we look at this angle, that's 90 degrees. And this entire angle is 90 degrees. Let's see, BCD is a straight line. Let's go ahead and mark that. This is a straight line. That's going to help us, I think, in the future. And according to our markings on here, we also know that this line is equal to this line over here, which makes that, this big triangle right here, that means, whoops, let's go back, see if I can get my thing back here. It means that that triangle is isosceles and that these two base angles are the same. Now, I don't really know if that's going to help us or not yet, but That's okay. We're just marking what we know. All right, let's see what we can do here with this information. So angle ACE. Well, we can figure that one out really quickly because we know that this whole angle right here, this was 90 degrees, and since it's being bisected right here, we know that that angle was split in half. So that's just going to be 45 degrees. Oops, that's not a percent. I shouldn't be writing a percent sign. That's what that looks like right there, isn't it? 45 degrees. Angle ACD. Okay, well, let's see. We already know this one up here, that's 45. We know that this has to be a right angle right there, so that's 90. So we can add those together and find the angle of ACD. That's going to equal 135 degrees. Let me mark that in a different color here. So this right here is 135 degrees. Well, now that we know the vertex angle of that isosceles triangle, I can find the base angles because all I need to do now is subtract 135 degrees and divide by 2. So when I subtract 135, it's going to give me the measurement for both of those angles. So I need to divide it by 2. So that's what I'm doing there. So if I subtract 135 degrees, I'm going to get, from 180, excuse me, I'm going to get 45 degrees. I'm going to divide that by 2, and I'm going to get 22.5 degrees. All right, let's do the next one. In this figure, PQRT is a parallelogram. Okay, I'm just going to stop, and I'm going to start marking this right away. So if this is a parallelogram, that means that opposite sides are the same. So those are equal, and then these two are equal. It also means that opposite angles are the same. So those two angles are equal. These two angles are equal. So just looking at this right now, if this is 62 degrees up here, this angle down here is going to be 62 degrees. Okay, let's keep going. QR equals RS. Okay, so this line equals this line. Well, that's convenient. That tells us that we have an isosceles triangle right there, and that those base angles are also going to be the same. So this angle is the same as that angle. Angle TRS equals 90 degrees, so that's this guy right here, and angle QPT equals 62 degrees. We want to find angle RSQ. So we want to find one of the base angles of that isosceles triangle. All right, no problem at all, right? So angle QRT is the first angle that I'm trying to find, and that's this guy right here. And we know both parts of that angle, one part is 62 degrees and the other part is 90. So all I have to do is add those together, and I'm going to get 152 degrees. Now I want to find angle Q. Oh, whoops, I just did that wrong. I'm sorry, you guys. That belongs down here. So let's write that on this one. I read those incorrectly. So that's 152, and then up here, this is the one that we already found because opposite angles in a parallelogram are equal. So that's this guy right here, QRT. Okay, and we marked that as 62 degrees. Now we want to find angle RSQ. That's this guy right here. So we're going to subtract 152 from 180 because all of the angles in a triangle add up to 180, and we're going to divide by 2. And we're going to get 28 divided by 2, which is going to equal 14 degrees. All right, last one. In this figure, ABCD is a rhombus. Let's stop right there. Let's just mark some stuff. If we have a rhombus, we know that all the sides are equal, so I'm going to mark them all with a little slash mark here. BE equals BC. Oh, well, that's convenient. So that means that this line equals this line, so it also equals those other sides. And angle CBE equals 50 degrees. Oh, okay, so that's 50 degrees. and we want to find angle DCE. Well, I can see right away that I have an isosceles triangle. So that means that this angle is equal to that angle because those angles are opposite the equal sides in my isosceles triangle. And those are going to be easy enough to find. So let's do that. We're going to subtract 50 degrees from 180 because we have this vertex angle right here. And then we're going to divide by 2. And we're going to get 130 divided by 2, which is going to be 65 degrees. So this guy is going to be 65. And this guy is going to be 65. So that's our first one. And then it says to find angle DCB. So this long angle right here. Well, how are we going to do that? Let's think about this for a second. Okay, well, in order to find that one, there are a couple ways I could go about this, but I'm just looking at this, and I'm going to go back to where it said that this is a rhombus right here. And since it's a rhombus, the fact that I have this angle bisector right here means that that's bisecting my angle exactly in half. So each one of those sides is 50 degrees, which makes the whole angle down there 100 degrees. And if I think about my parallelogram rules, I remember that consecutive angles in a parallelogram have to equal 180. So that means that this big angle and this big angle need to equal 180. Since this one's 100 down there, then this one must be 80 degrees right up here, okay? So that's the answer to this one right here. We wanted to find DCB, and that's going to be 80 degrees. Then we want to find DCE, which is that little tiny angle, and I'm going to make this a different color again. So we want to find this guy right here. Well, if we know the measure of this larger angle, which is 80, and we know the measure of this smaller angle, which is 65, all we need to do is subtract 80 degrees minus 65 degrees, and we get 15 degrees. And that's our answer. So again, you guys, these problems are all about just working on them and figuring out what you can figure out until you find the answer. And so they're just like puzzles. So I hope that they're starting to become fun for you. If they're not, keep working on memorizing those rules, because the more you're able to remember those, the easier these problems will be. That's all for today. If you need help, make sure you come and see me at recess. Thanks.